Right, let's review least common multiple from numbers, okay? You know the answers, but I'm going to show you how we do so we can use the same idea for expressions. 24 has factors. Factors are 4 times 6, so 4 means 2 times 2. 6 means 2 times 3. So I did prime factorization. 36, 6 times 6, 6 means 2 times 3, right? So 2i over 2, 3 times 3. So that is 36. So prime factorization. So I'm going to see the factors and then I'm going to see what is common. These are same numbers. So these together, these are going to be multiplied. That's called the greatest common factor. And we are very good at greatest common factor because we use those numbers for factoring. Least common multiple. And I use these numbers once again. All over these numbers, 2 times 2 times 3. And then I need to think about multiple. That means you should have every different part. This one needs to be multiplied. And this guy needs to be in the multiple. So let's multiply all and then we will have 72. Okay? So let's practice one more time with this new problem. 35. What are the factors of 35? 5 and 7. Factors of 25. 5 and 5. What is greatest common factor? 5. What is least common multiple? You put 5 once. Okay, once is enough for multiple. And then these guys, you need to have that factors in the multiple. So let's multiply 7, multiply 5, and answer was 175, right? Yep, that's how we do it. Now let's look at monomial. Monomial is with only multiplications. Multiplications only, that's monomial. Please look at me when I'm teaching, okay? So I can see you, you see me, and you can pay attention. Look at me. And you're not talking when I teach, okay? Alright, so let's do numbers. 18. Factors of 18. 9 and 2, so 2 times 3 times 3, right? 9 means 3 times 3. 15. 2 and 2, 3 and 5. So common factor 3. Least common multiple, I need to have those ones. Okay, right, ones. And then this one, and this one, and this one, right? And now look at the expression. I have variable x. Only once here, no x there. So I need to have factor x in the multiple. And now let's look at y variable. Y second, y third. What do I need to use? Second or third to make a multiple? Multiple means bigger number, okay? So I need to use y to the third power. So answer will be product of this. So let's multiply. 2 times 5, 10, 3 times 3, 9, 90, xy cubed. That is going to be called the least common multiple. If I use this as a denominator, this will be least common denominator. One more. 20. Factor 20. 4 times 5. 4. 2 times 2. 2 times 2 times 5. 16. 2 times 2 times 2 times 2. So I have a greatest common factor 4 between two numbers, and let's think about least common multiple. So bring down 2 one time and another set 1 time, and then use all the factors as a product. That's going to be a multiple. And then let's think about variable x cubed, x fourth power. What do I need to pick? Multiple. X to the fourth power, and then multiply all of this. Like I said, multiple, we have infinitely many cases. Out of those, I'd like to see the smallest one. That's why we have a least. So meaning is bigger number from multiple, okay? So let's put them all together. 2 times 5, 10. 2 times 2 times 2, 8, 80. X fourth power. Okay? So we talk about numbers and monomials. And actually today's lesson is with binomials. So let's look at the binomial case. This is 1, 2, 3, 4, 5. And number 1, can you tell me what is the least common multiple of 3 monomials? 2, 6, 4. What is the multiple of 2, 6, 4? 2? 2 is not multiple. 2 is a common factor, right? 12, correct. 12 divided by 2, okay. 12 divided by 6, okay. 12 divided by 4, okay. So 12 is a multiple number, right? Let's think about a third power, a fourth power, a third power. What do I need to have as a exponent? A to the fourth power. That's multiple, big guy, okay? Let's look at b. B to the second power, b to the fifth power. B to the fifth power. So with the variable, that's simple, right? Next one, number 2. I have 3 things. First, second, third. So let's look at the factored form of the first one, so I can see little parts. Do you remember I factored all the numbers to see the things? So we are going to do the same thing. First, let's factor. What is greatest common factor of the first one? X. And then x minus 3. Now let's check to find the least common multiple. Give me x, because I see same thing here, there. Alright, how many times do I write? Only once. And then let's look at x minus 3. Oh, how many times do I write? Only once. So this will be the answer, okay? Least common multiple is x times x minus 3, or you can say x squared minus 3x, because this has this part here and this also. Question number 3. What is the least common multiple of 2 binomial factors? Yesterday we talked about this a lot. You multiply, that is the multiple. Number 4. Do I just multiply to make the multiple? Not in this case, because this is possible to factor. What are the factors of x squared minus 25? X plus 5, x minus 5. So now let's see. Which one is common? X plus 5 is common. How many times do I write? Only once. And what am I going to do with this guy? Rewrite it, okay? So the first one was the multiple of the second one in this case. You can write this way, or you can say x squared minus 25 as a least common multiple. The last one, can we factor the first? X here, x there. What are the 2 numbers? 2 and 1 plus 1 plus 2. Second trinomial, let's factor. X here, x there. 2 times 3, right? Plus 3. So you factor first and then see little parts, and let's think about common factor. What is common factor? X plus 2. How many times do I write for the common factor here? Only one time, okay, in the least common multiple. And what am I going to do with this guy to make multiple? I need to multiply, okay? X plus 1, x plus 3. So my least common multiple will be cubic this time. When we are going to use this least common multiple, when we add rational expressions, we need to use least common multiple as same denominator. Okay? So that's going to be the same lesson from yesterday.